Let's solve this question about Lena, who is training to compete in the triathlon. So in the triathlon she needs to swim, and so in order to train to swim she decides to swim every Saturday. On the first Saturday she swims 500 meters. Then we're told that each week she swims 10% further than the previous week. And we have some questions here to answer about that. So let's first examine what's happening each Saturday. Incidentally, these solutions are summarized at the end of this video on one screen. If you want to flick to the end, you're welcome to do that. So let's understand this sequence of numbers. So on the first week, let's call it week 1, she swims 500 meters. On week 2, she swims whichever she does in week 1 plus 10% of 500 meters. And on week 3, she does whatever she does in week 2 plus 10% of whatever she does in week 2. So basically week 3 depends on week 2 and week 2 depends on week 1. So we see a sequence of numbers being so on week 2, week 1 is 500 meters. On week 2 we've got 500 meters plus 10%. Now we know we can find 10% of 500 by just dividing by 10. And so on week 2 she does 500, which is our original distance. She swims 50 more. Obviously she's feeling a little bit stronger. So she swims 550 meters. And then on week 3 she swims 550 plus 10% of that, which is 550 divided by 10. And make that 550 plus 55. It's giving us 605 meters. And so we can continue adding 10%. Here we added 10% of 500. Here we added 10% of 550. And so in week 4 we're going to have to add, we already swim in 605, add 10% of that, and we get 665.5 for week 4. So we can continue like that, or we can say, hey, isn't this the same thing as, isn't there a better way to do this? And so let's look at a better way to do this. So, starting again with a pen, we've got week 1 is 500 meters. Now to add 10% is saying that we want the original 100% plus 10 more, so we want 110%. Now we know that 110% is equal to 110 divided by 100, or the decimal value of that is 1.1. So if I want 110% of 500, then I'm going to take my number 500, multiply it by 1.1, which is 550. That's what we already said. That's week 2. And on week 3, I want 110% of week 2. Equals 550 times 1.1. In fact, for the next sequence, so we've got 550 times 1.1, 605, and then our next value, week 4, this is working out just like we already did, but this time we can see our sequence of numbers appearing in a more straightforward way. 110% of week 3 is 605 times 1.1, which is 665.5. And then we generate week 5. Let's skip that. 665.5 times 1.1, etc. In other words, we see we have a common ratio in this sequence. To generate the next term in the sequence, we multiply by the number 1.1. So let's summarize this as saying, oh, this is just a sequence question about a geometric progression. A percentage question is generally a sequence question, which is a geometric progression. So we have a GP, a geometric sequence, and the first term of our geometric sequence is 500, and the common ratio is 1.1. Now we understand the sequence of numbers, we're ready to answer the questions. Let's do it. Okay, how far does she swim in her second week? So we've already been using the notation WN to be the number of meters she swims each week. The first week we have 500, our second week 550 meters. Thank you very much. Next question. How far does she swim in her first week? Well, because we know it's a common ratio with the first term is equal to 500 and the common ratio is equal to 1.1, we can write it as a geometric sequence which has this form. So Wn is equal to 500 multiplied by 1.1 to the power of n minus 1. On our fifth week, we need to evaluate this when n equals 5. So W5 or go ahead and type into the calculator 1.1 to the power of 4 and we get 732.05. Now of course for the IB we need to write our values either exact or correct to 3 significant figures, so let's finish that up by saying 732 meters correct to 3 significant figures. Okay, so to answer that question we first wrote it as a formula and then substituted 5 into our formula. How far does she swim in total during her first 12 weeks of training? So she's been swimming for 12 weeks now and we want the total distance. In other words, I want to calculate the sum W1, W2, W3 plus all the way up to W12. Now since we have a geometric progression, we know the summation formula is this one. Now we simply need to identify our values. The first term is 500, common ratio is 1.1 and the number of terms we're adding is 12, so let's go ahead and plug those in. Notice that we're subtracting 1 after you've calculated 1.1 to the power of 12. Make sure you're not taking 1 up here on the index. And do get the calculator work correct. Particularly make sure that if you haven't calculated what's on the denominator, make sure you put the denominator into brackets. And so we get 1692 point blah blah blah. Again, correct to 3 significant figures, that's 10,700 meters. Just correct to 3 significant figures, we've got our first significant figure, second, and our third. Third significant figure is a 6. The next one's a 9, which rounds that up to 7. And obviously it's not 107 meters, that wouldn't be very far at all. It's 10,700, so I've got to keep these 2 zeros to make sure the place value, the magnitude of my answer is correct. Alright. What's next? Lena stops adding 10% to her distance on the first Saturday that she swims more than 2,000 meters. So she keeps adding 10%. And I'm wanting to know which week is it that's bigger than 2,000 meters. So to solve that, I need to solve the formula for Wn, which is 500 times 1.1 to the power of n minus 1. I need to know that this number here is bigger than 2,000. Now, I can do it by trial and error. I can do it on the calculator if I type in 500, then press enter, Then I ask it to multiply by 1.1. It shows up as answer times 1.1, and press enter, and then press enter, and then press enter repeatedly. Count the number of times you press enter until the first answer you get, which is greater than 2000, and that's you. That might not be a very satisfying approach, it's certainly limited, so let's have a more precise approach. A more precise approach we're going to reach for the graphing calculator, and we want to type in, we need to solve the equation, we want to find the x value where 2000 is equal to 500 times 1.1 to the power of x minus 1. This is our sequence, and if we find it when it reaches 2000, then we'll know when it's greater than 2000. So to proceed with that, I'm going to type in y1 equals 2000 and y2 is equal to 5000. y2 is equal to 500 multiplied by 1.1 to x minus 1. So I've done that on the calculator. I type in y1, y2. The tricky part here is to draw a good window. What we know about this graph is we want to include 2000 on the scale because we're looking for the answer 2000. That's why we've made the y minimum, the y value go up to 2500. Now in order to see the axis, I've chosen the scale 500, and the bottom number down here is minus 500. The top number is 2500, and each notch is worth 500. 500, 1000, 1500, 2000, 2500. So that's where we got our x values, our y values from. On the window, our x values is not so clear. This represents the number of weeks. So on week number 1, the answer here is 500. Week number 2, we know it's 550, and so on. And we want to know at which week she's swimming more than 2000. So I want to know what week that one is. In order to find that out, I'll find out the x value where the intersection is. So I don't know how many weeks there are. I want to see week number 1. I'm going to throw in a guess of 20 to begin with. And if it doesn't work out, if you can't see the intersection, then we just make a window a little bit bigger. So maybe you started with 10 and your graph was cut off around about here, and then you didn't see the intersection, then you know you've got to make the x value bigger. Alright, so with our window established, I hope you've got your graph drawn. We now need to find the intersection. So on 1.6 we learned how to find an intersection. Here it is again. And on the TI-84 I'm going to press second calc to get this menu, the calculation menu up for graphing, and I'm going to choose number 5. I answer the questions. First curve, press enter, yes, and it jumps to another curve. Second curve, enter, yes. Guess, move your cursor closer to where you want it to be, and then press go, and it should give you precisely this value down here. 15.545082. We should match with all our significant figures, should match right there. So in conclusion, we know at week 15, she swims less than 2000 meters, and at week 16 she swims more than 2000 meters. So 16th week is the first week that she swims more than 2000 meters. Again, there are several several calculator techniques to find that answer. Doesn't really matter which one you use. You might decide to draw a table. You might choose to just count the enters, like we said before. You might choose this technique, which is graphing, or you might learn how to use the solver on your calculator too. Any of those techniques work. It's just a matter of choosing one technique and getting good at using it. So here's a summary of the solutions to this question. And that will be all about this question regarding Lena. Good luck, Lena.